Thanks for having me again. So my name is Kamrul Hasan. I'm working as a cloud solution architect at a company called Intelligent Cloud. So it's a startup selling managed cloud services built on top of Azure and other cloud platforms. Essentially, we are hiding the complexity of the cloud and exposing a simple interface for our clients and the partners. So a little bit more. So I've been working in this industry more than 7 years. My primary focus is on cloud platforms, and my addiction is to design and architect serverless application for modern software appliances. So I love to learn more than I teach, and I'm a huge fan of automation. So eventually moving my career towards DevOps arena. Thank you to our global sponsors and supporters. Special thanks to Microsoft, Google Cloud, Red Hat, and Melissa for supporting this event and inviting me as well. So this is our agenda today for my presentation. During initial episodes, I'll talk about the open source project, which is Apache Spark. Spark is a cluster computing framework. Then I'll move to explaining Spark on Azure, which is actually called Azure Databricks, its ecosystem and feature details. And at the ending, I'll be doing a short demo explaining the overall UI of Azure Databricks. Then I'll do a short application which will be detecting anomaly from streaming data from Twitter live streams. So moving on. So let's talk about Apache Spark. So Hadoop and Spark execution model is very similar. Basically, Hadoop breaks down its task into MapReduce jobs and eventually runs aggregates to the master and publishes the results. Its primary focus is on disk space and I/O. But whereas Spark, keeping the distribution of job in a similar model, it actually uses disk I/O and memory, so giving it a huge performance boost over Hadoop MapReduce jobs. It uses a resilient distributed dataset, or called RTD, which is called directed acyclic graph, to complete this job. So at a very high level, this is two different engineering way this two system operates. So Spark actually performs very well on top of HDFS file system, and it actually runs 100 times faster than average MapReduce job running on Hadoop HDFS file systems. Spark is actually written in Scala, whereas Hadoop is written in Java. So the in-memory processing of Apache Spark enables it to process batch real-time data and in an iterative and interactive fashion, whereas Hadoop only supports batch processing. Spark is relatively easy to use considering all the other programming model and APIs it offers, but running a small program like a word counter in Hadoop's master node is a little bit complex and lengthy, whereas a word counter program may take like 100 lines in Hadoop cluster, where as Spark can do it in few lines of code. Spark offers caching in memory, and which actually enhances performances, but Hadoop does not support caching of data. So that's why we are seeing a very much good progress of Spark from open source as a Apache project. It moved to industrial arena and getting a very good market and doing very well against Hadoop. So this is in-depth and more in-depth look inside Hadoop's Apache Spark's internal and ecosystem and some deployment model. Here you can see Spark is written in Scala, as I've already said. It provides high-level API, and this API actually enables it to support scripting languages like Python and R. Spark actually supports ANSI SQL and HypeQL. There is a Spark streaming internal library that actually enables Spark to process streaming data. There is a machine learning library and a graph processing engine as well. So you can run them using the provided API from the core system. Now, there are several modes that Spark supports to run a big production grade job. So Spark runs on Yarn, which is, if you expand its name, it's called yet another resource negotiator. Spark supports meshes as well, and you can actually run Spark in standalone mode. So Yarn allows you to dynamically share, centrally configure the same pool of cluster and resources between all frameworks that runs on Yarn. And Mesos, as a distributed system kernel, it has high availability for master and slave architecture. It actually run the Spark application in parallel with Docker-based systems and other Hadoop-based MapReduce jobs. So what a development team actually do is that they leverages the Spark standalone mode and they develop applications locally. Then when they are satisfied with their initial POC and MVP, then they deploy their application on Yarn or Mesos to enable it on a production grade scale. So this is the Spark's job scheduling and scheduling at scale internally. If you look into it, then you can see Spark applications are run as independent set of processes on a cluster mode, coordinated by Spark context, which is actually runs in the driver program, which is the master node actually. And at Yarn mode, each application gets its own container. As you can see on the screen, the submitted job is distributed into multiple worker nodes where each Yarn execution container has its own executor, caches, and HDFS data node. Spark acquires the nodes in cluster which actually processes the applications in parallel and run computations and store data in the application. This has the benefit of isolating the application from each other on both the scheduling side. And because the driver schedules tasks on the cluster, it should run close to the worker nodes, preferably in the same network. So in the cloud, they actually run in the same VPC to get the performance boost. Okay, so now that was the Apache open source Spark. Now we are going to talk about Spark on Azure Databricks. So these are the feature lists of Azure Databricks, and from the left hand side you can see the ingestion features that Azure Cloud Platform offers for Databricks. You can actually ingest data from anything, from IoT to Hadoop storage to data warehouses, on-premise data warehouses. Then data gets into a collaborative workspace where you have a notebook, which is a web-based interface to document that contains runnable commands and visualization and narrative texts. Then you have a dashboard. Dashboard is as an interface that provides organized access to visualizations. And you will have real-time co-authoring, commenting, and automated versioning collaboration support on the notebook itself, which I'll be showing shortly during our demo time. Then after the collaboration and working out the data and reporting and business logic part, you can actually quickly discover new insight, and you can schedule the figured out business logic and ultimate artifact to schedule it on a machine learning and data pipeline at scale. And you can actually even configure a CI/CD pipeline and create multiple stage pipeline using notebooks workflow that Databricks actually offers. So this is a high-level architecture where how it is actually showing how Databricks operates on Azure Enterprise Cloud. So Azure Databricks is actually a Apache Spark, a Databricks developed by the Databricks team, and it is combining with Enterprise Cloud, that is Microsoft Azure. So it offers high-speed connectors to Azure storage services, and when a customer actually launch a cluster via Databricks, a Databricks appliance is deployed as Azure resource in the customer's subscription. Then the customer specify the types of VM to use and how many nodes they actually requires. But Databricks actually manages all other aspects. In addition to these appliances, a managed resource group is deployed into the customer subscription that gets populated with a virtual net, a security group, and a storage account offered by Azure. So these are the concepts Azure users are familiar with. And once these services are ready, then users can manage the Databricks cluster through the Azure Databricks UI. And there are many features to take care of, like auto scaling, metadata, job scheduling, and geo-replication for fault tolerance. So these are the overview of Azure Database. Now, what I can do, I can quickly log into my virtual machine provided by Hasan Bhai and to check if I can show you guys the demo. So the demo is also divided into two parts. Here at the first part, I will just briefly walk through components of Azure Databricks and then quickly jump into the anomaly detection application that I have talked about. So if you go to Azure's home directory, you can just quickly search Azure Databricks. As you can see, it is already on my home screen. Then if you click on it, then you can creating a Databricks instance is very easy. You just have to click here at the add button and fill up some details, and the workspace will be ready for you. Then once it gets ready, you can just you'll get a short URL, which is if you click on that, then the database instance will be launched, and the authentication mechanism is totally taken care of by Active Directories. Now, if I quickly go through the front-end part of the UI, you can see you can do a very there is a very good section here, which is a quick tutorial. If you quickly run through this tutorial, you can very much cover like 80% of the features Azure Database actually offers. So this is a Zeppelin notebook instance like notebook. You can run SQL, you can run Python, you can run Scala here, and you can get different types of plots and visualization available here. So this is very handy for data scientists and data engineers to get a quick visualization over their work. Now let's walk through the workspace section. So you can see creating a workspace is very easy. If you just you can create a shared workspace. You can see here I have created 2 shared notebooks, but you can create personal notebooks as well. And once you create your own notebook, you will just get a blank notebook here, which is very handy to use. And if you look at the data section, you can see the number of backend, data backend Azure Databricks actually support. So here you can actually upload your own JSON or CSV file to analyze it here. And Databricks has its own file system, which is called DBFS, Database File System. And from here you can explore your Delta Lakes. This is a new concept leveraged or delivered by Databricks to us. So this Delta Lakes actually works based on checkpoints and other snapshot feature of our data storage. Then it supports other data sources as well. For example, there is a very good support for Azure Blob Storage and Azure Data Lake Store. These are very important for Azure users, but it also supports Redis, Kafka, and Elasticsearch. So configuring this from this notebook is very easy. So moving on to the cluster part. Creating a cluster is very easy in Azure Databricks. So cluster have two categories. There is a dedicated resource pool. For example, once you create a cluster, the boot up time sometimes it takes 1 or 2 minutes. If you want to don't want to get blocked by that, then you can create a dedicated resource pool. But let's for this demo purposes, we'll use a general purpose cluster here. So if creating a cluster is very easy, you just click the create cluster and fill up some details here. You can see there are two modes for cluster modes. There is high concurrency mode. This is very expensive, and you can use it if you are dealing with large scale data processing. So for our demo purpose, we'll go with the standard one. So here is a pool section as well. If you create a pool, then the pool becomes available here as well. Here you can select all the runtimes that you are willing to use. So there is a GPU runtime for machine learning based frameworks. If you are working with ML based application on this notebook, then these runtimes you want to check out. And so moving on to next feature here, you can see you can very easily enable auto scaling feature. What auto scaling actually does is that it lets you set up minimum number of workers and maximum number of workers. If you disable that, then you get a flat amount of worker nodes for your job. And this setting is very important. You need to check this. By default, it is checked. So if somehow your cluster sits idle, then after inactivity of 120 minutes, it will automatically die. But you can easily reconfigure it from the dead cluster using the same configuration. Now, in terms of choosing the instance type that you will be using for your worker nodes and master node, you can choose from Azure Compute Pool. You can see that there are many compute options here. Even you can get almost like 672 GB of memory and 96 core cluster nodes for your jobs. So I wish I can use that one day. So for this job, for this demo, we'll be using the minimum level instance for our demo that we'll be doing soon. So this is the cluster overview. So once a cluster is created, then you can easily inject your own dependencies. If you go to cluster details, you can see the library section. Here you can inject your own libraries. So for this demo, then that I am about to show you has two dependencies. I have injected them here. You can quickly see event log from here. You can see Spark UI and driver logs. There is matrix section, and there is Spark cluster UI snapshots available here. So these are some details here. I think I need to quickly move to the demo application that I'm about to show you because I'm running out of time. So this is the last part. Here you can actually schedule jobs once you are ready. I mean, the notebooks is for experimentations, and after your experimentation turns into a real life application, then you can easily schedule or deploy your application from this service. So here you can schedule your daily jobs here, or if you prefer a cron like expression, you can set it up here as well. So these are the overview from the UI perspective. Let's get into the application that I want to show you. So at a very high level, the application that I'm about to show you is divided into two parts. One notebook will be pulling streamed tweets from Twitter. Then it will be posting the tweets into Azure Event Hub. Eventually, this notebook will be acting as a producer, I mean data producer. It will pushing the time series data into Azure Event Hubs. Then this particular notebook, which is a consumer notebook, will be pulling that stream data on a interval basis from the Event Hubs and run anomaly detection on the target tweets using the Anomaly Detector, which is Azure Cognitive Service, and we'll be doing the whole thing using Spark API. So let's get back to our notebook. Okay, so you can see this is the producer notebook, which actually sends a tweet to Azure Event Hubs. I have already created Azure Event Hub account and got the credential from that. So if I just quickly run it from here, you can see this program, what it is trying, it is trying to attach this particular job to the running cluster, which is attached to this particular notebook, which actually takes few minutes, and eventually once the job is done, then it will actually start pulling tweets from the Twitter. And what we are doing here, we are actually tracking Azure's Azure hashtag at this producer notebook. So you can see the job is already submitted and the command is running. Let me just quickly run this notebook as well so that we can cover the time here. So you can see it has started to stream the tweets pulled from the from Twitter to Azure Event Hubs, and so it has turned itself into a data producer. Now let's move to next notebook that we have. I'm not sure how much time I have left, but we'll see if, okay, so the first cell as
Kamrul.
So
hello.
Yeah.
Kamrul, please carry on.
Okay.
You have at least 15 minutes.
Oh, thank you. Okay, so I will be needing that 15 minutes, I guess, because this demo requires some more time. Thank you. Okay, so I have just ran my first cell. Here, what is happening is that it is actually declaring an anomaly detector class, and it is attaching itself to the event hub that I have just configured at previous notebook. So it is declaring its anomaly detector class. Here it is preparing its connection string and few helpful method to detect the anomaly from the time series data that we have. So I have just ran this cell. So let's move to next cell. Here what is happening is that we are declaring our anomaly detector aggregation function. and later at the later cell we'll be using this aggregator function to aggregate and normalize data that we are pulling from Twitter. So let's run this as well. Okay, so it just ran. So it didn't take time because it is not doing any job. It is just declaring some classes and functions. So the real jobs actually get started here. So here you can see we're loading data from Event Hub at this section. So if you quickly go through the code, you can see I'm defining a connection string here to Azure Event Hub. Then I'm defining the incoming stream. Once this cell is done, data will be continuously pulled from Azure Event Hubs and continuously it will be streamed on the UI. So I've just run the cell and you can see the job is running here. And Databricks has done a very good job of showing the visibility is very nice in Databricks. You can see each and every part of the job that is submitted to the cluster, and the results is really near real time. You can see that stream data has already started coming through. So these are the Twitter's track tweets that we have. For example, here we are tracking Azure hashtag and posting the timestamp and the likes to our Event Hub event bus. And here we are actually pulling the data from that. Then at the next section, you can see here data is not that much evenly distributed. So we'll have to just normalize and clean up the data to get some normalization into it. So here I'm running a window function which will run on and divide this data into hourly windows. And after that, we'll detect, we'll run anomaly detection function onto it. So you can see the Spark job has already been submitted, and here the stream is already getting processed here. So the real beauty of this particular stream processing is that the notebook is holding the session with event hubs and continuously pulling dynamic data. So as you can see, as the data is streaming continuously, you can do anything with it, right? Data is continuously rolling through this pipeline, and you can run, you have a Jupyter notebook where you have Spark in it, then it actually gives you lots of possibility and opportunities. So you can see by default, Azure Database has given me some visibility options. For example, I can see bar charts, I can see line charts, and this is really important for data scientists to get some visibility from the data. So at the next cell, what we'll do, we'll just push this normalized data into Azure's or Databricks Delta Lake. So I'll just quickly declare a snapshot. For example, a snapshot need to be a unique one so that we can get or create analytics from that particular snapshot in point in time. So let's I'm running that cell. So when this cell run, then what will happen is that data will be getting processed through all these pipelines, and the processed data will be continuously streamed into the database new concept, which is called a Delta Lake. So this Delta Lake is very popular, and I have heard news that Amazon cloud platform and other cloud platforms was really feeling threatened about this Delta Lake concept, because when you run a transformation and migration job using a big data cluster, what it does is that it runs a CDC on existing database and pulls events from the upstream system as in a append only fashion. But in Delta Lake, there is no append only. Data gets updated immediately. So that actually helps a lot for migration and other transformation jobs. So here you can see data is continuously getting into the Delta Lake. Now I'll just quickly do a check on the Delta Lake whether data is there or not. So as you can see, there is some data into Delta Lake, and it will be continuously getting populated. But the problem is we have defined an hourly window. So within that window, within this short time, it is not possible to show all the functionalities. But what I'll do, I'll just take a snapshot or a point in time data from here and show whether this particular data point is anomalous or not. So here you can see it's a 20. For example, if I take this data, it is a 2029 and 24 and 12, 4 and this. So in practice, what you'll do, you'll have to just define a job and put a scheduler in front of this notebook, so that you need to set your target data points so that you can easily and periodically get your anomaly detection at your desired downstream system. So I have just ran the anomaly detection function here, and you can see the anomaly detector aggregation function that we declared in the top cell that I was talking about here, actually here. So this function is has got registered into Spark's SQL context, and we're actually using that function to detect anomaly. And you can see here that this particular data point has gone to anomaly detector and came back as a false position. So this data is not anomalous actually. But if we look into this one, and at a bare bone, I mean, looking into this pattern, I think this particular data is has some anomaly in it. But let's just check it. 9, 24, and 15. So I've just ran it. I'm not sure what will be the result, but let's just see what happens. Okay, it is also false, but probably this is happening because the lack of data. But if we run this stream application for like 1 or 2 hours, then more data will be coming through. There will be a pattern established. Then each and individual points will show its own results, whether there is anomaly or not. But looking at this particular window snapshot, looks like Azure streaming on Twitter is quite normal. So thank you, everyone. I hope this was useful. Hasan, back to you. And if there's any question.
One question come, what will be the cost of this implementation? If you can have any idea, please share with the audience.
Okay, so it actually depends based on the cluster size that you will be using. So for example, here, what I've done is that I have set up a minimum cluster, which is 8 GB memory and 4 core, which is a least expensive cluster here. and I have turned on the auto scaling feature. So it actually depends on the cluster size or amount of workload you are trying to process. So based on the cluster size, you can just quickly go through Azure's instance pricing list, and calculating the overall cost is very easy.
Actually, in generally, for a manufacturing company, say mid-size company, if want to implement it, what will be the cost that he actually want to know, uh, or or is there any source from there he can assume the idea of cost structure if he wanted to implement it?
I'm not sure about what kind of implementation that you are expecting, but it is actually depending on the workload that we'll be putting on the cluster, and based on the workload, the cluster size will be defined. But you can quickly go to Azure/Databricks and get the cost details.
Thank you very much. Second question has come. How can a person can get idea about the Azure Databricks, or if you want to know or learn Azure Databricks, how he can do it?
Okay, so a person with a credit card can easily sign up for a trial in Azure and try the service hands-on. And for a person without any credit card, he can quickly start with the native Databricks a community edition. For example, the Databricks has its own site. If you can quickly Google it, you can go to Database official site and sign up for a small demo machine. Then you can quickly run your experiments there. Then for your production workload, you come back to Azure Database and set up your account and do it. Yeah, but you can actually, so the summary is you can practice your Databricks skills and learn it and grow it on Databricks native platform if you don't have any credit card. But if you have any credit card, then you can quickly sign up for trial account in Azure and go through the trial and get all the skills. And getting a good skill or expertise over Apache Spark is the most important part here. So learning Apache Spark is very easy. You can just fork Apache Spark from here, and then download the open source and software and run it on standalone mode on your local laptop or local machine. Get habituated with all the APIs, go through the programming guides, then practice all these, get the concept and learn and practice all